Have you ever found yourself doing tough binomial expansion or probability without a calculator? We have the solution for you. Pascal's triangle, a triangular number pattern that shows us things from the powers of 2 to how to solve probability problems. First of all, how do you make Pascal's triangle? First, you start off with the number 1 at the top. Then you move down diagonally, adding 1 space each time. As you go down, add the 2 numbers next to each other to get the number below. A blank space is a 0. The first row with only 1 is row 0, and the row with 1, 1 is row 1, and so on. And look at that, it's Pascal's triangle.
Here is one out of many cool features in Pascal's triangle. Try adding all the numbers together in each row and see what you get. You'll notice that each row is a power of 2.
Pascal's triangle is also super helpful in binomial expansion. Each row gives you the coefficients for each of the terms in the expression a plus b to the x, where x is the row number. For example, let's substitute 3 in for x. Start by going to the third row of Pascal's triangle. Then create a big addition problem with those coefficients, which are 1, 3, 3, and 1. Next, put one of your variables, a, next to the first coefficient and raise it to the power of the row number, which is 3. Continue putting a's next to each coefficient, but each time raise it to 1 less of the power you had before, so a squared, a to the first, and a to the 0. Do the same with the other variable, b, but start on the opposite side and go in the opposite direction. Now you have successfully expanded your function into 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed.
Pascal's triangle can also be used to figure out probability problems. If you are trying to figure out, for example, the probability of a coin landing on heads twice with 4 flips, you would first create 4 rows of Pascal's triangle and go across to column 2, not counting column 0. Then add up all the numbers in that row, which equals 16. So the answer is 6 out of 16 chances of landing on heads twice with 4 tosses.
Pascal's triangle interested us because even though it is a simple number pattern, it can be used to help solve some pretty complicated problems in half the time and without a calculator. It was interesting to see all the patterns it showed in the numbers that make it up. Although we weren't able to share all of them, we thought it was pretty cool that things, even as complicated as the powers of 11, were in the numbers.
It also really helped with our understanding of things like probability. Sure, you can use an equation, but does it really help you see exactly how you are getting to your answer? With Pascal's triangle, we were able to see exactly what was happening by moving down the triangle and across the row. Pascal's triangle is a very versatile number pattern that can reveal tons of different and helpful mathematical patterns.